Hello everyone and welcome to quadratic function and equations lesson number 3. So last lesson we looked at what the values of p and q change in our standard form of our quadratic equation, and today we're going to look at what the value of a does. So we know that our equation is y is equal to a multiplied by x minus p squared plus q. So in the last lesson we looked at how q changes the vertical position of the vertex and p changes the horizontal position of the vertex. And we can always write the vertex as pq. And today we're going to look at what the value of a changes. So it says here we have the graph of y is equal to x minus 2 squared shown, and you can see that we've shifted 2 units to the right, 1, 2, right there. And now what we're going to do is we're going to multiply that whole function by 2. So we're going to get y is equal to 2 x minus 2 squared. So that's our a value. We've got an a value of 2 there. And we're also going to do the same thing with 1/2. So we're going to set our a value to 1/2. And we're going to look at what happens. So let's look at 2x first. So that's the one they want us to look at right here. So let's compare the graph to y is equal to f, or to f of x. So let's bring this up. So you can see I have the y is equal to x minus 2 squared as a reference. And what's going to happen, I'm going to open up the one where we multiply by 2. And you can see that it gets skinnier. I know that seems super weird, but if you look at the y-intercepts, it's a little bit easier to see what's going on. You can see here that when x is 0 in our original graph, when x was 0, y was 4. When x is 0 in our new graph, y is equal to 8. It's almost like it's been multiplied by 2. Weird. So we actually call this a vertical expansion by a factor of 2. So it's like we've been stretching the graph upwards. So the y-intercept of the graph is double, or twice, I guess double is the word they're looking for. Double the y-intercept of the graph of y is equal to f of x. So now think about what's going to happen if we do the same graph but with 1/2. Let's bring that up. You can see that it's wider. So the y-intercept of our original graph was 4, and now the y-intercept of this one is 2. So we call this a vertical compression. So it's like vertically it's been pushed together or compressed down by a factor of 1/2. The y-intercept of the graph of y is equal to 1/2 x is half the y-intercept of our original graph. So in math, the general name given to an expansion or compression is a stretch. So it's a vertical stretch, and it's anchored by the x-axis. And what that means is the x-coordinates of every point on the original graph don't change, but the y-coordinates are multiplied by whatever a is. So it says here, describe the effects of the parameter a on the graph. Well, it's a vertical stretch. Let's roll this up a little bit. Vertical stretch by a factor of a. Compare the graph of y is equal to x squared. The graph of y is equal to ax squared results in, or compared to that graph, the graph of y is equals ax squared results in a vertical stretch of a factor of a about the x-axis. So if a is greater than 1, the parabola undergoes a vertical expansion. And if a is between 0 and 1, the parabola undergoes a compression. So this would be a fraction or decimal, but most of the time just fraction. Now let's look at what happens when we have negative a values, which is totally allowed to happen. Oh, I dropped my pen. Give me 1 second. Oh, that's the first time I've ever dropped my pen in a video. There we go. Back in the saddle. So what I want to do is they have y is equal to x squared as a reference here. And we're going to graph y is equal to negative x squared. And we're also going to graph y is equal to negative 2x squared. And we're going to have a look at what's going on here. Anyone have any ideas what to expect? Share in the comments, I guess, if you want to. So I have x squared up here to give you a reference. And now I'm going to bring in negative x squared. That was anticlimactic. There you go. It is upside down. Yay! And negative 2x squared is upside down. And it's been vertically stretched, which we expected. So let's go back to the notes here. Let's fill this out. So we have the first one is y is equal to negative x squared. Our vertex is still at 0, 0. So you remember it was something like, oh, what's happening? Something like that. So our vertex is still 0, 0. Now, instead of a minimum, because we flipped it, that has become a maximum. It's the top, right? It's the peak. And it's also at y 0. The equation of the axis of symmetry is still through x is 0. And it's called, we had a reflection in the x-axis. So if you look at that graph, it's like there's a reflection about the x-axis. The x-axis is the edge of the water, and you can see that it looks like it's a reflection. It's upside down. So the next one is y is equal to negative 2x squared. And on the last page, or on the last investigation, we looked at what happens when we change that value. So it's been expanded by or stretched by a factor of 2, and it's negative, so it was flipped and expanded by a factor of 2, so it was something like that. That was bad, but you know what I mean. So again, our vertex is 0, 0. We have a maximum at y 0. Our equation of the axis of symmetry is still x is equal to 0. So now we have a reflection in the x-axis and a vertical stretch of 2, by a factor of 2. Let's write that. That's better wording, sorry. Vertical stretch by a factor of 2. How does the graph of y is equal to negative x squared compare to the graph of y is equal to x squared? Well, it's a reflection. So when it's negative, oh man. When it's negative, it's a reflection in the x-axis. It flips. I always think that if it's negative, right? If it's negative, it's unhappy. So it's a frowny face. And if it's positive, it's happy. So it's a smiley face. Whatever way you want to remember. I'm a little bit silly, I guess, in my math memory devices, but that's okay. So compared to the graph of y is equal to x squared, the graph of y is equal to ax squared, where a is less than 0, it results in a reflection. This is really, I hate these wordy wordy explanations. So it's a reflection in the x-axis and a vertical stretch by a factor of a about the x-axis. So they sum everything up here really nicely. So it talks about the values of a, p, and q. So this is a really nice page to have handy here. So it says here, a indicates a vertical stretch about the x-axis. If a is greater than 1, there's an expansion. If a is a fraction, there's a compression. And if a is negative, there is also a reflection. It flips upside down. P indicates a horizontal translation. If p is greater than 0, the parabola moves p units to the right. If p is less than 0, or negative, the parabola moves p units to the left. And q indicates a vertical translation. If q is greater than 0, the parabola moves up q units. And if q is less than 0, parabola moves q units down. P and q are the coordinates of your vertex. And the equation of the axis of symmetry is x is equal to negative p. So this is a fantastic summary sheet right here. I'll probably end up getting you to put this on your graphic organizer, your final project graphic organizer. Okay, I'm going to skip this one, just time-wise. You just watched a really... Oh, no. Oh, the pages got folded. That's okay. We can fill this in. It's totally okay. Hopefully in your book you can see that on page 288. It says, unless otherwise indicated, use the following order to describe how to transform from one graph to another. So the order is a little bit important. It's important to start with your stretches, whether it's being compressed or expanded. Then talk about your reflection, whether it's negative or if it's flipped upside down or not, and then translations, left, right, or moving up and down. So the first equation is, that's funny that happened. The first equation is y is equal to negative 1/4 x squared. So we're going to start with our stretches. So describe how the graphs of the following functions relate to the graph of y is equal to x squared. In this case, we're starting with our stretches. So we have a vertical stretch by a factor of 1/4. And we have, now we're going to talk about our reflections. It's negative 1/4, so we have a reflection in the x-axis. And there's no translations because we have no p or q value. So we're done. Now we're going to do the same thing for the next one. We have 1/3 y is equal to x plus 6 squared. The first thing we want to do is deal with that 3, right? We want to get rid of that 3, so we're going to multiply 3 to both sides. 3 over 3 cancels, and I'm left with y is equal to 3x plus 6 squared. So we have a vertical stretch by a factor of 3. And we have a translation. We don't have a reflection. It's not negative. And so we skipped a translation. We have a translation of 6 units. And this is the one that's always opposite. So we're going to 6 units to the left. There we go. We'll do the last little bit here. Oh, computer's a bit glitchy today. The following 3 transformations are applied in order to the graph of y is equal to x squared. A reflection in the x-axis, a vertical stretch by a factor of 1/3 about the x-axis, and a translation of 7 units right. At the end of the three transformations, the point 1, t is on the resulting graph. Okay. So we need to create our equation. So we start with y is equal to x squared. And the first thing that happens is a reflection in the x-axis. So that means that we're going to have y is equal to negative x squared. Then we have a vertical stretch by a factor of 1/3 about the x-axis. So that's our a value. So now we're going to have negative 1/3 x squared. And the last thing we're doing is a translation of 7 units to the right. 7 units to the right is going to be negative 7. So this becomes y is equal to negative 1/3. And that's a p-value, so it's x minus 7 squared. And that's our equation right there. So state the coordinates of the vertex of the final graph. So we know the coordinates of the vertex are p, q. So in this case, it's going to be 7, 0. We don't use negative 7 because the p-value, it's x minus p. That minus is supposed to be part of the equation. The p-value is just what's right there. So it's 7, 0. Find the value of t. So basically, it said the point 1t is on the graph. And we need to find the value of t. Well, it's giving us the x value. We just need to find the y value. So we know y is equal to negative 1/3 x minus 7 squared. So what we can do is plug in our x value, right? Y is equal to negative 1/3 x is 1 minus 7 squared. 1 minus 7 is 6. Negative 6, sorry, squared. Negative 6 squared is 36. And 36 divided by 3, or 36 multiplied by negative 1/3 is going to give us negative 12. So our value of t is negative 12. Sorry I'm moving through this really fast. It's just they're big videos and I'm trying to make them as short as possible. Complete the following table. You know what? Maybe we'll do this one in class and then we'll cut it right there. Thanks for watching. Don't forget to like and subscribe.